In this video, I'm going to just give you an introduction to trig identities in grade 11. And so you've got tan x can become sine over cos, sine x over cos x. If it happened to be tan 2 theta, that would just be sine 2 theta over cos 2 theta. I saw a question today, if it was 6 tan theta, it becomes 6 sine theta over cos theta. It doesn't become 6 sine theta over 6 cos theta, because then 6's would cancel and it wouldn't be back to what it was. And so that's just a quick explanation about tan theta and how tan theta is always waiting there for you to expand. So if you see it in a proving identity question, it's pretty much you always want to expand it to sine over cos. If you're working in a question and you're sitting with something like this, and you can see that the answer that you're trying to prove the identity to be has tans, then you can magically divide every term by cos. So you can magically introduce dividing every term by cos, because then sine over cos would give you tan, and the coses would cancel and leave you a 3. So that's also another way to look forward to what you might be needing. Then the other set of identities that you predominantly face in grade 11 is when it comes to squares. And when you see squares, your brain must start buzzing like an alarm system going off. That sine squared plus cos squared equals 1. And if I rearrange this and I took the cos across, then sine squared would equal 1 minus cos squared, and cos squared equals 1 minus sine squared. So these three, you're just constantly buzzing anytime that you notice that there's squares. Be careful if you had something like sine squared x plus cos squared y. That doesn't equal 1. It's only if the angle is identical. Another cool trick is if you had 3 sine squared x plus 3 cos squared x, then the answer to that would be 3, because you could just take out a 3, and in brackets you'd have sine squared plus cos squared, which is 1. And so just look out for that. Whenever you have the same coefficient for both, the answer can just be that coefficient. Then another helpful thing is that, I'm not saying you do it every time, but let's just say you've somehow noticed that cos squared, little cos squared, can become 1 minus sine squared. Then there will be many times in your proving of identities career that you can do a difference of squares to this, and it becomes 1 plus sine x in brackets 1 minus sine x. So something so tiny like this can become this massive thing. Another thing that can be helpful is, again, I saw a question that was something like this today in the middle of a proving identity question. And 1, not that you have to expand it every time, but there's massive power in 1, because 1 can be sine squared plus cos squared. And so this little one, I could say sine squared x, I'm going to write the plus cos squared x at the end. So that's what 1 became. And in the middle, I've got 2 sine x cos x. Why did I do that? Because it might lead to some kind of trinomial. And so how do I get sine squared x? It would be sine x and sine x. How do I get cos? It would be plus and plus, cos x and cos x. And so again, this is very powerful, this little number 1, when it comes to identities. So as you go deeper into the section, as we in future videos go through more intricate identities, allow yourself to just buzz when you see a tan or when you need a tan. And also buzz when you see squares, that it can become any of these 3 variety of identities, and then the power of 1. I hope you found this video helpful. If you did, please like it, subscribe to our channel, and share it with your friends. Thanks.